Welcome back, Night Owls. This is Dr. Nighttime, and tonight I'm going over one particular past exam problem from LTAM that covers covariance of insurance products, or certain insurance products, specifically life insurance. It's not a particularly complicated problem, but there's one moment in here, one step in here, that I thought made this worth making a video out of. So here's the problem as it appears on the SOA problem list. Z1 is the present random variable for an n-year term insurance of $1,000 issued to an X-year-old. Z2 is the present random variable for an n-year endowment insurance of $1,000 issued to that same X-year-old. For both Z1 and Z2, the death benefit is payable at the end of the year of death. The expected value of Z1 is 528. The variance of Z2 is 15,000. And then the next two pieces of information they give relate to the pure endowment, right? Notice that this A value, this is the value only if the n years pass before the X-year-old dies. That's a pure endowment. So you get that the expected value of the endowment is 209 times the sum insured, and the expected square value of the pure endowment is 0.136 times the square of the sum insured. Notice that anytime you have this square for the 2 here, that is going to scale with the square of your sum insured. And then it says calculate the variance of Z1, the term insurance. Well, since these last two relate to a pure endowment, I figured it's nice to give the pure endowment a name. I called it Z3. Right? Z1, Z2, Z3. You'll notice that the endowment insurance in Z2, that's equal to a term insurance plus an endowment. So for any given life, Z2 is going to be Z1 plus Z3. So immediately one thing we could say is expectation of Z2 equals expectation of Z1 plus expectation of Z3. Hopefully you remember linearity of expectations. They give us expectation of Z1 is 528. Z3, we said that expectation of Z3 was going to be 0.209 times sum insured. The sum insured was 1,000, so expectation of Z3 is 209. You add those together, you get 737. Okay. Now let's look at the variance. Well, variance is mean of the square minus square of the mean. So for this, I'm going to want the expectation, I want to look at expectation of Z2 squared, because Z2 is just Z1 plus Z3. Now, intuitively, you'd either try to say, well, are Z1 and Z3 independent? No, they're not. If they were, I could just say variance is going to be, so variance of the sum would be sum of variances. If they correlated perfectly, I could try to get it in terms of a single variate distribution, but here, all I have to do here is FOIL it out. And this looks scary at first, right? You FOIL it out, you get expectation of Z2 squared equals expectation of Z1 squared plus expectation of Z3 squared plus 2 times Z1 times Z3, all inside the expectation. I get this. And this 2 times Z1 times Z3 looks scary at first until you realize for any given life, well, either you die within the 10 years, in which case Z3 is 0, or you survive the n years, in which case Z1 is 0. So either Z1 is 0 or Z3 is 0. So that means 2 times Z1 times Z3 is always 0, right? I multiply two numbers together and one of them 0, the product is 0. So I can just get rid of this term. Expectation of Z2 squared equals expectation of Z1 squared plus expectation of Z3 squared. I know that expectation of Z2 squared is variance of Z2, which they told us was 15,000, plus expectation of Z2 quantity squared, right? This is just a reformulation or rearrangement of variance equals mean of the square minus square of the mean. It's saying mean of the square equals variance plus square of the mean. So I crunch those numbers out. I get that expectation of Z2 squared is 558,169. Expectation of Z3 squared, we said that was going to be 1,000,000 times the double interest rate expectation of sum insured of 1 for the pure endowment, right? So we said that it's going to be 0.136 times a million. It gets us 136,000. So that means, plugging it back into here, if this expectation of Z2 squared is 558,169, and this expectation Z3 squared is 136,000, that means the expectation of Z1 squared, just with simple algebra, has to be 422,169. And variance of Z1, variance is mean of the square, which we just calculated as 422,169, minus square of the mean. Way back at the beginning of the problem, they told us expectation of Z1 was 528. So we do 422,169 minus 528 squared to get 143,385. So the one step in here that I'd say you want to try to remember, and they'll sometimes ask about, is that if you can express something, an insurance as a sum of a term insurance and a similar endowment, one of those two has to be 0, so when you FOIL it out and multiply, the product will always be 0. And that's how you, for this one special case, right, typically variance of a correlated sum isn't going to be anything nice. You either have to know the correlation coefficient, or you'd have to have some relationship between them, right? So because if you live more than n years, then the term insurance is 0 and the endowment insurance is not, and the other way around. So they're clearly negatively correlated, but calculating the correlation coefficient isn't going to be that easy. You pretty much have to do this procedure to calculate it. So because of that, we'll need some other way of finding the variance of this sum of two correlated random variables. And this is one of the tools you should have in your toolbox. When you FOIL out the sum, you get first 1 squared plus second 1 squared plus twice the cross terms. Sometimes that cross term has to go to 0. This is one of those times. I hope you found this useful. And as always, if you like the way I explain things and want to arrange private lessons, click the link in the description below. And until next time, this is Dr. Nighttime wishing you a good night.